Hello everyone. In this video we're going to learn how to solve and apply right triangles. Some of the topics we will visit include significant digits, solving triangles, and some applications having to do with angles of elevation or depression. One of the topics that you will encounter mainly in your science classes, but also in some mathematics classes, including trigonometry, has to do with significant digits. Basically, significant digits are digits that are obtained by actual measurement. Um, the result of a calculation is no more accurate than the least accurate number in the calculation. So you have to always keep that in mind when you're trying to determine the level of accuracy of a particular calculation. To maintain accuracy, always use given information as much as possible and avoid rounding off in intermediate steps on your calculator. So if there's a large calculation to be done with several steps, right? You don't want to do one part on a calculator and then get round the answer for that part and then bring it in, put in another part, etc. What you want to do is try to type in the entire expression, no matter how complex it is, in one fell swoop, because in that way you will minimize the amount of error involved in your calculation. Here we'll go over the rules for determining the number of significant digits. These have a tendency to confuse some people. I've tried to make it as simple as possible to understand for you here. So firstly, notice that all non-zero digits are significant digits. When you look at an example like this number right here, 985,432, would have 6 significant digits. Captive zeros, all right, that means zeros between two non-zero digits, they're always considered to be significant digits as well. So as you can see, this number right here, 23.10045, would have 7 significant digits, and these two captive zeros would be considered significant. Leading zeros are never considered significant digits. So that means if you look at a number like this, all these are considered leading zeros and they would not be considered significant digits. This number right here would only have 3 significant digits. Trailing zeros in a number containing a decimal point are always considered significant digits, such as this, right? Because usually these two zeros are included to indicate that the level of accuracy has been to 4 decimal places, right? So this would be considered to have 1, 2, 3, 4, 5, 6, 7, 8 significant digits. Trailing zeros in a number not containing a decimal point represents an ambiguous case, okay? They are significant, such trailing zeros. Notice this one does not have a decimal point. This is a whole number. Such zeros are significant only if they're obtained through actual measurement, which is almost never the case in this kind of a scenario, right? So trailing zeros are almost always not significant, okay? It is an ambiguous case, so it depends on the particular situation you're dealing with, but the safest thing to assume is that those trailing zeros are not significant. When there is a decimal point involved, however, and there are trailing zeros after the decimal point, always consider those to be significant. When it comes to determining the number of significant digits for answers and applications of angle measures, we use this convention as outlined in this table. For angle measures to the nearest degree, such as 62 degrees, 36 degrees, we consider the answer to 2 significant digits. To the angle measures to the nearest 10 minutes or 1/10 of a degree, such as in these two cases, we consider these to have 3 significant digits. Angle measures to the nearest minute or hundredths of a degree, such as in this case or in this case, these we deal with 4 significant digits. And angle measures to the nearest 10 seconds or nearest thousandth of a degree, such as we can see in here. We have 1, 2, 3, 4, 5 significant digits. As I said, you will mostly encounter significant digits in science classes, but every so often you'll encounter them in a mathematics class as well. So I thought it would be good for us to go over them. All right, now on to our more classic trigonometry concepts. Notice that we've already hinted at what solving a triangle means, and it's basically nothing more than finding the measures of all the 3 angles and the lengths of all 3 sides. If you find all 6 of those pieces of information, then you have solved a triangle. Our initial focus will be on right triangles, and this is the naming convention for right triangles. We will use the letter C for the right angle. A and B can be either of the 2 acute angles. It doesn't matter which one you put where. The side opposite each capital letter will take length with lowercase level. So this side will have length lowercase c. The side opposite angle B will have lowercase b for its length, and the side opposite angle A will have lowercase a for its length. We've already seen that. Now we're going to actually formalize the notion. All right, so we're going to use our information regarding right triangles to go ahead and try to solve this triangle that's depicted here. All right, so we notice that what's missing is angle M here. We need to find out what that is. These 2 angles we already have measures for. This is 49.5 degrees, and this one is obviously 90 degrees. So the easiest thing would be to find the measure of angle M right now. So the measure of angle M is obviously 90 degrees minus 49.5 degrees, right? Remember, this is 90 degrees, so those 2 must add up to what? To 90 degrees. We've talked about that. The 2 acute angles of any right triangle are complementary. So if you know one and you want the other, you can just subtract the first one from 90 and you'll get the measure of the other. Now, of course, you could use the triangle sum theorem and say this plus 90 plus this equals 180, etc. But why, right? When you can do it in a much simpler manner in this way. So we get the result of this. Let's go ahead and figure it out. Many of these calculations we can do in our heads, but it's always good to be safe. We don't want to lose points, say on a homework or a test for simple calculations. Here we have 40.5 degrees. All right, so we know the measure of angle M, so we have all 3 angles now. Now we need to work on finding side labeled N and the side labeled P. Now, I can use either angle M, which I now know is 40.5 degrees, or angle N to get either of those sides. Let's go ahead and start with angle N and try to see if we can get the measure of N from it, right? So we notice that we have an angle. We want the side opposite, and we know the side adjacent. So this is where SOHCAHTOA will come in really handy. So which of these 3 functions deals with opposite and adjacent, right? Notice that that would be the tangent. So that's what we're going to utilize. So we're going to say the tangent of 49.5 degrees equals opposite over adjacent, right? So n over, notice that the side opposite is n and the adjacent side is 121. So now if we just cross multiply, imagine a 1 under the tangent, so we get n equals 121 tangent of 49.5 degrees. All right, so now all we have to do is we have to make sure we're in degree mode. Okay, you do that at least once per session to make sure, you know, somebody hasn't played with your calculator while you have been away from it, etc. And then we go ahead and multiply 121 by tangent of 49.5 degrees. All right, so we notice we got a negative result, right? So that means there's something wrong. Let me go back to the settings page, see if, yep, it's in radian mode. You see that? See, but if you're alert and you know that you should not be getting a negative result for a side of a triangle, you'll catch that. So somehow I put that on radians before. Now I'm going to click somewhere else so that that change takes effect. Now I'm going to go ahead and go back. Now all I have to do is just click that, double click that, it comes back. Now when I hit enter, not like that, like that, now we get the correct answer. So 141 point, let's just go ahead and go to two places on that. So 141.67. So now we want to go ahead and find side P, right? Now I'm noticing here that this one is actually given to us in only 3 significant digits, or in this manner as a whole number. So let's go ahead and go with that convention and actually round this to what? 142. That would be more consistent. So approximately 142 there. Now we're going to find side P. Now we have options at this point. Given that I now know n is 142 and this side, which is lowercase m, right, is 121 meters, what I could do is I could use the Pythagorean theorem now to try to find P. Or I could use the sine again for 40.5. I could go sine of 40.5 equals 121 over P and get my result that way. So depending on which one you prefer, you can use that method. I'll go ahead and go with the sine method, and I'll show you that you can do the Pythagorean as well. So we know that sine is opposite over hypotenuse, right? So 121 over P, and we cross multiply, we get P times sine of 40.5 degrees equals 121. So P equals 121 over sine of 40.5 degrees. All right, so 121 divided by sine of 40.5 degrees, and we get 186.3. If we're going to go with the same number of significant digits, we'll round this to 186, right? So we get approximately 186. Okay, so we have all the pieces now, right? So we have solved the triangle. Just so you know, we could have also done this. We could have said leg 1 squared plus leg 2 squared equals hypotenuse squared. So 121 squared plus 142 squared equals hypotenuse is p, so p squared. So p would be the square root of 121 squared plus 142 squared. All right, be really careful. The square root of a squared plus b squared is not the square root of a squared plus the square root of b squared. Be very careful with that, okay? That is definitely not the case. So what we need to do is just plug it in. So we get the square root of 121 squared plus 142 squared. And notice we get something close, not exactly the same, but close, right? So so in this method, if we actually do the rounding correctly, we do actually end up with approximately 187. When you're doing, this is why when you're doing assignments on, for example, my math lab, they usually have a range of acceptable answers which they will accept because of these different methods and different types of rounding that may take place. Okay? All right, so make sure you can handle something like that before we proceed. All right, so in this one, the picture is not provided for us, so we're going to come up with the image ourselves, and or the diagram. We want to round the side lengths to the nearest tenth and the angle measures to the nearest 10 minutes, which basically means, of course, that we need to put our angle measurements in a DMS format, right? Degrees, minutes, seconds, etc. All right, so if we just go ahead and draw a right triangle. Now we know that this is going to be C, it's 90 degrees. And where I call A and B is really not that important. We can just go like that. Now, but I do know once I decide that A is going to be the side opposite angle A, so right here. And B is going to be the side opposite angle B, right? Well, from at least my figure, it looks like it's better if I switch those. Call this A and call this B, right? Because that's longer, right? Just to make it look more consistent with our drawing, right? And B, which is opposite angle B, is 41.9. All right. So we have two angles that we need to find and one side, right? Side which we will label with C. All right, so notice that we have different options that we could use, right? We could use, for example, angle B, because we know the opposite and the adjacent. So for example, we could use tangent here. In fact, let's try that. Tangent of B is going to be, again, let's remind ourselves of SOHCAHTOA, right? So tangent is of course opposite over adjacent, so it's going to be 41.9 over 78.1. Now, if the tangent is that, if we want to know the angle, we need to use the inverse tangent. Remember, tangent of theta equals A is equivalent to saying that theta is the inverse tangent of A. So B is going to be inverse tangent of that fraction. All right, so let's clean this up a little bit. So we get shift tangent, the arctangent or inverse tangent of 41.9 divided by 78.1. All right, so we have 28.2. So approximately 28.2 degrees. But remember, we want to write the angles to the nearest 10 minutes. So we're going to say that 28 minutes, and we're going to take the 0.2 and turn it, 28 degrees, my apologies, and the 0.2 we're going to turn into minutes by multiplying by 60, and that's going to be in minutes. So that's 28 degrees. 0.2 times 60 is 12, but since we're rounding to the nearest 10 minutes, that'll be just rounded to 28 degrees 10 minutes. Okay, all right, so we can now get the third angle, angle A, because remember this is angle B, by doing this. We have B equals 28 degrees 10 minutes. So as we know, A is just going to be 90 degrees minus that. Remember, the two acute angles of any right triangle are complementary. They add up to 90, right? So let me get rid of this SOHCAHTOA now. So remember, in order to be able to do this subtraction, I'm going to have to borrow a degree and turn it into minutes. So that's 89 degrees 60 minutes minus 28 degrees 10 minutes. So that gives me 50 minutes here, and that's going to give me 61 degrees. All right, so there is angle A. So here we have B, we have A, we know C is 90, so nothing to do there. So there's only one thing left to do, to find the measure of the side labeled lowercase c. So that, of course, we don't even need trig functions for, because we have two sides of a right triangle, and all we need to do is go ahead and use the Pythagorean theorem. L1 squared plus L2 squared equals hypotenuse squared. So 78.1 squared plus 41.9 squared equals c squared. C is the hypotenuse, so c, applying the square root property, is going to be the square root of 78.1 squared plus 41.9 squared. Now we just need to go ahead and compute that. So we just want the square root of 78.1 squared plus 41.9 squared. Okay, now we get 88 point so and so. Notice that we want the sides lengths rounded to the nearest tenth as we agreed. So to the nearest tenth, that's just going to be 88.6. So C is approximately 88.6. Now, do we have all three sides and all three angles? We do. Okay, so if you want to be really organized, you could do the following. You could just list them all in a nice fashion, like this. So you could say A equals the result that we found, (61 degrees 50 minutes). B equals 28 degrees 10 minutes. C is of course 90 degrees. Lowercase a equals 78.1. Lowercase b equals 41.9. And lowercase c is, we found it to be 88.6 right here. So I mean, if you really want to show that you've solved the triangles, you just represent the three sides right here, the lengths of the three sides and the measures of the three angles, and then there's no doubt that you have solved it. All right, so run through that, make sure you can do it without a glitch, and we'll move forward. All right, for the second part of our lesson, we're going to look at some applications of what we have learned, and they have to do with angles of elevation or depression. All right, so the angle of elevation theta from a point A to a point B above A is this acute angle right here that's formed by ray AB and a horizontal ray AC, which has endpoint at A, right? So you want to know what's the angle of elevation from this point to this point. You're going to draw a horizontal from that point, the initial point, right? And then you're going to measure this angle that this ray AB makes with that horizontal ray, and that is the angle of elevation. The angle of depression phi from point A to point B, somewhere below A, of course, is the acute angle formed by ray AB and the horizontal ray through C with the end point at A. So again, you want to know what's the angle of depression from here to here. You're just going to draw a ray that's horizontal and then calculate that angle, that acute angle, and that will be the angle of depression. All right, a 10.5 meter fire truck ladder is leaning against the wall. Find the distance d the ladder goes up the wall if the ladder makes an angle of 26.45 degrees with the horizontal. So they're not actually naming this an angle of elevation problem, but that's exactly the scenario here, right? They're giving you an angle of elevation and they're asking you to find the length, which we can do, of course, because we have access to trigonometric functions. That's where their strength lies, right? They help us solve applications. All right, so how do we find d, this distance, right? Because remember, we want to know how far the ladder goes up the wall above the fire truck, right? So we're only asking for this distance, not from the ground, right? So if we could find that if we knew the height of the fire truck, right? So we do know the length of the ladder. So we have this angle. We know this side, which of course is the hypotenuse of this triangle here. And we want to know this, the length of this leg. So let's bring back our friend SOHCAHTOA. So we have an angle, we want the opposite side, and we know the hypotenuse. So which of these three involves the opposite and the hypotenuse? The sine, okay? So we just set up sine of 26 degrees 45 minutes. We know that that should equal to the opposite, d, over the hypotenuse, 10.5. So if I imagine a 1 under the sine and cross multiply, I get d is equal to 10.5 sine 26 degrees 45 minutes, okay? So we just need to do that calculation. So 10.5 times sine of, now remember, the best way to handle that, just turn it into pure degrees. So 26 plus 45, we're going from a smaller unit to a larger unit, so we divide, remember? By 60 by the conversion factor, and there we go. 4.726, etc. Remember, we're supposed to let's see if we have rounding instructions. They do not give us rounding instructions, so we'll just go with 3 significant digits, right? So 4.73. And of course, you always give your final answer the units. Here we'll have meters. All right. So there's a nice simple application, and make sure you can handle that, and we'll proceed. Okay, so here we have a slightly more interesting problem. From a window 33 feet above the street, so from here, the angle of elevation to the top of a building across the street, so this angle right here, is 54 degrees, and the angle of depression to the base of the building across the street is 17 degrees. So this angle right here is 17. Find the height of the building across the street. So we want to find this height. It almost at first look seems like they may not have given us enough information, but when you patiently think about it for a while, you realize we might just have enough, okay? Notice that they say this angle is 33 feet, this point of view is 33 feet above the street, right? So that means when you drop a perpendicular like this, this piece right here is also going to be 33 feet, right? So that's where all the fun begins. Now, if we use a proper function, we should be able to get this length right here, right? Because we have an angle, we have the side opposite, and we want the side adjacent. So let's go back to our friend SOHCAHTOA. Which one is it that deals with an angle, the side opposite and the side adjacent? Right there, tangent. So we're going to use tangent. Let me call this one x, and later we're going to find this piece as well, which is y. Then we can find the sum of those two, and we'll have the height of the building. But notice we have to find x before we can find y, right? We have to have something in this other triangle other than just what? Just an angle. That's not enough. All right, so that's why we have to find x first. Okay, so notice that we can use tangent as we just agreed. So we get tangent of, remember, at any point when you feel like, oh, okay, I got it, and you think you can do the rest, you should stop the video, go do the rest, and then come back. Because remember, if you watch a video like this as if it's a movie, you're not going to get anything out of it. This has to be completely interactive. You have to have paper and pencil in your hand. You have to be working this stuff along with me. All right, this is not just something you watch. Math is not a spectator sport, right? It's a completely participatory sport, so you have to be completely dived in. All right, so we get tangent of 17 equals 33 over x. At first, that sounds really scary when you're not used to doing it for many, many years. But if you just be brave and try it a few times, yeah, it might be very frustrating. It might take you a long time to eventually adapt, but it's well worth it. You won't recognize yourself if you decide and actually follow through and do what I'm suggesting you do. All right, so if you throw 1 under this and cross multiply, we get x times the tangent of 17 degrees equals 33. So x equals 33 over tangent of 17 degrees. All right, so 33 divided by tangent of 17. Just real quickly, I will make sure. Yes, we're in degrees still, so we should be fine. So we end up with 107.9, etc. We'll just round this to 108. So x is approximately 108. Now we're going to use this fact that this is 108 to come up with another trig function that's going to give us y. Think about what that would be, right? I hope you said tangent, right? Because we have the opposite and adjacent. Of course, maybe you said cotangent. That's okay too. Adjacent over opposite, no problem. You could use that too. But why is tangent better? Because tangent is what's available on a calculator. That's why it's better. So in other words, it's not that it's better, it's more efficient. Otherwise, cotangent would have been just as correct to use. All right. So we have tangent of 54 degrees equals y over 108, opposite over adjacent. So cross multiply to get y equals 108 tangent of 54 degrees. So 108 times the tangent of 54 degrees. So we get approximately 149. And the height of the building is that whole thing. So if we call that h for height, h is going to be y plus 33, right? So 149, which is y plus 33. So, and of course, remember, we've rounded, so this is going to be an approximation. So we end up with 149 plus 33. So 182. Notice that if there's one approximate symbol in a chain, then the final result is an approximation, right? All you need is one. So I don't need to keep putting it at every step, because all I need to write it is once. So basically, the height of the building across the street is approximately 182 feet. It's a word problem. They ask us properly, we'll answer properly, right? So we'll use a full sentence, put the units in the final answer, the works, right? All right, and that's a nice application. So again, make sure you can handle this completely on your own. Now, even if you looked at what we did together, that's fine. Now just, copy the question, and without any help whatsoever, you should be able to generate the answer on your own without having to keep looking back, right? Because as long as you do, you're not finished with the concept. All right, let's move on to another one. All right, so here's another one where we have to come up with the sketch on our own. The shadow of a vertical tower is 75 feet long when the angle of elevation of the sun is 32 degrees. So basically, we have a tower. It's a vertical tower. It's casting a shadow of 75 feet, and the angle of elevation of the sun, so from any point on the ground, is 32 degrees. Okay, now we notice they're giving us 3 significant digits in each, so that's obviously the way we want to compute our answer. All right, now we want to find the height of the tower. So remember, the sun is somewhere up here. All right, now h is what we're looking for. We have an angle. We want the side opposite. We have the side adjacent. Again, our good old trustworthy friend SOHCAHTOA, right? Notice tangent keeps popping up, doesn't it? Yeah, tangent is really useful when it comes to these kinds of applications. All right, so tangent of 32 degrees equals h over 75, opposite over adjacent. So h is 75 tangent of 32 degrees. Now let's calculate that. 75 times tangent of 32. So we're going to go with 3 significant digits, so 46.9. So approximately 46.9 feet, of course, because the units here are feet. And these trigonometric ratios don't really have any units, right? Because they're just the ratio of 2 quantities with the same unit, so they get canceled out. So these are just pure numerical ratios, right? All right, so a simpler one, I guess. Make sure that it definitely is the type that you can handle, and we'll proceed. All right, here's our last problem for the day. Yay, huh? Okay, so from the top of a 210-foot cliff, David observes a lighthouse that is 430 degrees feet offshore. So here's a lighthouse. David is looking from up here, and we want to find the angle of depression from the top of the cliff to the base of the lighthouse. Now, the reason that this is important, and I wanted you to see it before we end the lesson, is because a lot of times students incorrectly label this part as the angle of depression. Remember, the angle of depression is always the angle that is made with the horizontal from the point of view, right? So first you draw a line from the point of view to the observed point, and then you draw a horizontal through the point of view, and the angle that's formed between those two rays will be your angle of depression. So let's go ahead and call it theta. Now if you notice, this line and this line here, if you imagine a line here, would be parallel, right? So this could be considered a transversal. So this angle is going to be an alternate interior angle with respect to this angle, and we know that alternate interior angles are congruent when a transversal cuts through a pair of parallel lines. So this would be theta as well, right? So if we find this angle, we've also found the angle of depression, right? So that's exactly what we need to do. So what are we going to do here? Well, we have an angle, the side opposite, the side adjacent. Does that sound familiar by now? Once again, tangent comes to the rescue. So the tangent of theta equals 210. Let me show you the units just so you can see what I was talking about in the last example. See, these cancel out, don't they? So tangent is a pure ratio, see? So this time, let me rewrite that now without those units. So tangent of theta equals 210 over 430, right? Now, we have the tangent, we want the angle. So what do we need? We need the inverse tangent. Remember, tangent of theta equals A is equivalent to saying that the inverse tangent of A equals theta, okay? So theta is going to be the inverse tangent of 210 over 430. So let's go ahead and compute that. So arc tangent of 210 over 430. So we get 26.02, etc. Now notice that we're dealing with actually two significant digits here. Remember, those trailing zeros when there is no decimal are not significant. So with two significant digits, our answer will be approximately 26 degrees. All right. So that's how you would find an angle of depression like that. All right, so that brings us to the end of our session. These are some nice applications. Make sure you get comfortable with them, practice them on the homework, and stay safe till our next meeting.